Yes. So I'm going to talk very briefly about clay. I just want to introduce a little bit what clay is. And then I will, I was asked to talk about strategies in clay, so then I'll present 5 points to you of what I think are important things we need to do to build more in clay, and at least also they reflect what we have been doing at AHO, me and my partner Lina Brustrom, who have been teaching a lot and experimenting with clay among other materials. Clay, when we talk about building with earth, we're really talking about using binders, or like a, where do I point? Yes, there. Using clay as a binder. And when we think about clay, it's really not very different from other binders in the sense that, or other composites, I should say, in the sense that we're always working with a matrix. I think I have a no, yeah, okay, it comes later. And then it belongs in a way to this family then of powder looking like binders. Clay is in fact something that when you burn with lime is what gives us Portland cement. So there's a lot of connections in there with concrete. And it's basically really small fraction. It is basically like a 1 millimeter divided over 500, and then that's the size of the clay particle. So you can see in this diagram, this is if a grain of sand is this big, then a grain of clay is that small, and it's a byproduct of like natural phenomena. So it's not something that we manufacture. It's something that we find, and it's quite available around the world. And it has a crystalline structure. So basically, when we're working with clay, what we're doing is that we are working with these faces or like plates, and the structure that is generated between them. And it is more flexible than cement, Portland cement, for example, in the sense that it has the ability to hydrate and dehydrate, so then these bonds can change more easily if it's unburned. But it has, in a sense, a very similar structure to that of Portland cement, which is also crystalline. And then, well, in here I'm missing, is there a pointer? No? This here, there, I think I found it. That's a plus. Then going back to this idea of the composite, when we're working with clay, then when we talk about earth architecture, then what we're talking about is working with composite that often involves some form of aggregate. These aggregates can be of many kind, and then a binder. So it's a matrix that is holding everything together. And I've worked a lot with concrete before. I have a bit of a specialty on it, so I can help to always remember that in material science, concrete is much more than just Portland-based concretes, but it's understood as a composite of granules that are held together by a binding agent. So therefore, earth is a concrete made of clay. And I think this is a very good thing to remember, because the industry sometimes is very reticent to think of clay as something that is very strong, or earth like a concrete, but it really it is a form of concrete. So it's and very much like concrete, we're talking about the same things. We have water, and then clay will be our cement, and an aggregate. And then one can also work with different forms of reinforcement and additives, which can improve our mix and the way we work with it. And like I said, you can use many different types of aggregates. So stones and sand are of course really good and common, but also unlike Portland-based concretes, we can use a lot of natural types of fibers and aggregates, like wood, straw, hay, hemp, rice husk, coffee husk, and all sorts of things, because in that sense clay allows everything to breathe, so it won't rot inside. And also very much like working with concrete, it's about how you put things together. It's about that mix and the distribution of the elements that you're putting in, the different types of proportions that you use, the quantity, the size, and the form of the elements that go in. So it's really, in many ways, like cooking or baking a bread, right? And the water-cement ratio applies also in here. So water-clay makes a big difference. You want to have enough clay to bind everything together, but you don't want also too much of it, because then it becomes a little bit more unstable, and you have a lot of problems with volumetric stability, for example. But clays are available all over the world, and they differ very much in look and qualities. For example, reds and yellows have a lot of iron oxide, and then white has a lot of titanium dioxide. Here in Norway, we have a lot of what we called leire, blue clay, which has a lot of cobalt in it. And it really looks actually like cement or like concrete, like normal gray. So you can see, it also has some cadmium in it and so on. But going back then to why clay is very interesting, it's because not only we really find it everywhere, but it is antibacterial, it's hygroscopic, meaning that, again, it breathes, it lets moisture travel, so things won't rot when you work with natural materials. It doesn't burn, or it's not flammable. One can burn it. That will change also the way it works. That will be ceramics. It has very good acoustic properties. It's anti-static, and then one can really find it on the ground on many parts of Norway. You can use the site excavation to source your own materials. So the economy of it could also be a point. And then, then again, very much like with any other material, depending on what you're going to do, you need to think about how you're going to treat it. So the type of element that you want to build will determine different techniques. One thing to note is that traditionally labor has been demanding when working with earth, but this is something that is changed a lot, or we have many different options today. So it tends to take a little bit of time because of its relationship to water. It's not like with Portland cement, for example, you have a chemical reaction that occurs really quickly. With lime, it's a similar reaction that occurs more slowly, but with clay we don't have that chemical reaction. It's a mechanical reaction, so then it takes time for things to stabilize and harden. And one has to, of course, consider how we will be exposed to what type of weather, and then also plan ahead, thinking about maintenance. And this is again to remember, like, it really is found everywhere. So it's a very common material, and it's something usually, maybe some of you know this already, but if you dig usually about 1 meter down, that's where you find big deposits of clay. And then what you find in there is also often varying in amounts of clay, so you have to study it. but then it has been a material, because it's everywhere, it has been a material that has been used for centuries. So here come my 5 points, done with my introduction. One, we need to learn from the past, because we have so many good examples of really incredible works of architecture or infrastructure done just with clay. These are, of course, this is in Africa, and here we have in China. We have villages in China, for example, that are still, using these techniques to maintain their villages. A little bit closer to home, we do have also traditions of building with earth in Europe. But more importantly, I think it's really important to think about your context as well. So something we have done, for example, in the school where we taught last year one course called Constructive Logic, Earth Matters, and then another one called Constructive Logic, Wasted. We were looking very much at what we call tech, traditional ecological knowledge, really looking back at what has been done on site. And we found that here in Oslo, without going too far, there's a lot of examples going from the late 1800s. This house, for example, is in Sankthanshagen. There's a whole neighborhood made with earth. And this is in the outskirts of Oslo. There's quite a few houses around made with air-dried blocks. And we find also that this is a material that it was always used when there was economic crisis, right? So there was a lack of resources. Then we went to earth. And during the post-war periods, there was even a Jordhus booklet, or actually it was called the Jordhuskontoret, that put up this book so that they could encourage population in Oslo and Norway in general to rebuild their own houses with earth, and they were using air-dried blocks for this. So with the course, we did a lot of mapping. We tried to identify some of these houses. We didn't have the capacity to map everything. We also collected samples across Oslo, so the lighter dots in there are samples that we collected. And we tried to also study and make booklets of both the examples of the houses we found. Often these houses were part of full neighborhood projects, so it's representative of one way of building. We looked at the history and the techniques they used, and then we paired that with also the samples of local soils. So the second point then is when working with clay, you really need to get your hands dirty, meaning that you need to touch and feel the material, because every hole you dig will give you a slightly different sample. We found in Oslo we had huge diversity of types of clay, and also or earth, and then the earth that you dig out, or the soil, it also has different proportions of clay and sand and silt. So whenever you're going to use this, you need to study it. And we spend a lot of time with the students just characterizing it and also playing with it and trying to understand how to work with it in a bigger scale. Third point is also to document the work. I think this is particularly useful today, and for us it has been very important, so that we can communicate with each other what we learn, because a lot of the traditional knowledge is lost, and there's very few people building with it in Norway right now. So that's what we've been trying, going beyond for photographing, to also document all the experiments and work with the scientific method as a very important component, because it also addresses the production of knowledge through architecture, which I think it's something we don't often discuss. So how do we test and characterize these materials, and how can architectural means interpret our findings in a way that creates new knowledge? These are comparative granulometry studies, and also examples of how to find the right consistency when working with earth. Fourth point is to think big. And when I say think big, I mean scalability. I think our biggest challenge right now is not to build houses, but is how to scale, how to build bigger buildings with clay. So we have been looking a lot at logistics and trying to work with industrial scale buildings and programs with the students to think about also mass production and how to deal with labor in a different way, especially in the Norwegian context where we have very little access to labor. And the last point is then to share it, to share this knowledge, make it accessible and make it fun. And in an attempt to that, we have also tried to make exhibitions with the material that we have produced, try to get everyone to work with it. This is not clay, but it's part of one of the studios, and we have a student there. I think you should talk to him about also hay and straw. He was very keen on that difference. And working with different types of fibers, for example, and not just in this case, we have also experimented with hemp and limes and different types of binders, trying to understand what is the effect of mixing them together. And that's it. I think that's,
Thank you very much, Andrea. Very interesting to see your thorough studies of the building materials. And in Norway, we actually have between 11 and 21 million tons of excavated soil each year, and we only make use of about 20% of it. So this is a large building material, untouched building material that is you probably get paid for using. So it could be interesting. And I remember during the Corona lockdown, we all got very good at baking bread. So let's get down and dirty and start baking buildings. It should be good.
Before I can just pass this around,
please,
if that is
please
okay, because I brought a lot of samples. And just very quickly, this is pure clay from Tosen. And then I will pass others. This is just, clay and newspaper mass. And then, yeah, I will pass some more than those are labeled. This last one is not clay, it's hempcrete, but we're big fans of hempcrete, slime and hemp. And I should say that most of the soil that we excavate is in Oslo, in the Oslo area, is automatically considered contaminated. So it will not only be disposed in landfills, but it will be considered toxic. So if you're working on a project, make sure that they test it, because it's very cheap to test it, and then it means that you can just put it somewhere else if you're not using it. But most of it is not contaminated, actually.
Thank you, Andrea.